I'll push something to get this up here. There we go. Okay, so let's take a look at this problem. We got H naught says P is equal to 0.50. H1 is P is less than 0.50. N is 300. X is 141. Okay, B. If researchers decides to test this hypothesis that alpha is equal to 0.05. Computed probability of making a type 2 error, beta, if the true population proportion is 0.47. What is the power of the test? Looks like they don't give us anything down here. Okay, so I think that's everything from the problem. Okay, step 1. Write down the claim. Now, there is no claim. They jump directly to null and alternate hypothesis, which is step 2. That's already done. Draw the picture, determine the tails. Now, I don't give any kind of indication here, but well, let me bring it up. Okay. Where in the world would that be? I think it was 10.2. I think I have some pictures there. I just want to refresh your memory and all the different, which one to look at though? Oh, this one. Should be up in just a second. I should have had that on here. Remember, if it's a not equal to, it's two tails. If it's a less than, it's a left tail. If it's a greater than, it's a right tail. I always think of this when you got the less than and greater than, which way it's pointing. This is pointing left, so it's a left tail. This one's pointing to the right, so it's a right tail, in terms of inequality. And this, well, I don't know any way to remember that. Okay. So, over here, when it says draw the picture, that's based upon what we've seen already. See how this is pointing to the left? So this will be a left tail. Okay. Now it says find ZA sub L and or ZA sub R. If it's on the left side, it'll be a ZA sub L. Now the Z is our critical Z-score, and I don't really have anything to refer to on that. But remember, on a calculator, to find critical Z-scores, it's always I and V norm, and I and V norm is always the area left. And I couldn't even tell you what slide that's on. Okay, so it's a left tail, so this tells us do an I and V norm alpha. So I and V norm of alpha is 0.05. So ZA sub L is going to equal second bar's I and V norm, 0.05, gives us something. Now here, note specifically I say round to 3 decimal places. So this is negative 1.645. We round up because of that 8. That's our ZA sub L. Okay. Next step is we got a left tail. So this says find P hat sub L and or P hat sub R. You'll have both for 2 tails, round to 3 decimal places. Okay, so for the left tail here, that tells us we're going to have P hat sub L is going to equal to P naught plus ZA sub L times the square root of P naught times 1 minus P naught divided by N. Now, usually I have it somewhere on the slide here on this process. You see it says here P naught is a number from the claim, or from H naught H1. So P naught is the 0.50. So that's going to be 0.50 ZA sub L, which is minus 6 or 1.645, then square root of 0.50 times 1 minus 0.5. Let's try that again. 1 minus 0.50 divided by N, and N was 300. So P hat sub L is going to equal to 0.5 minus 1.645 square root, so second x squared, 0.5, and then times 1 minus 0.5, which is 0.5, divided by 300. Now, always very important on these that you pay attention to what it says decimal-wise. It says round to 3 decimal places. So this is going to be 0.453. Okay, so now multi-step problem. Find Z sub L and or Z sub R. And left tail, we're going to find Z sub L. So we got Z sub L is going to equal to P hat sub L minus P over square root of P times 1 minus P over N. And down here it tells you P is the true population proportion in decimal form. And we're going to round this 2 decimal places. Okay, so P hat sub L from down here was 0.453 minus P, and that's our true population proportion, which is 0.7 or 0.47 over square root of 0.47 times 1 minus 0.47 divided by N, which is 300. You put that in, you have to make sure you put parentheses on the top part. Okay, so 0.453 minus 0.47 divided by square root 0.47, beginning parentheses, 1 minus 0.47, close parentheses, divided by 300. And 2 decimal places, we get negative 0.59. Okay. Still dealing with the left tail, so it says beta is going to equal to normal CDF of Z sub L, comma E99. Z sub L is negative 0.59 E99. So second vars normal CDF negative 0.59 comma second comma 99. Well, we'll get back there eventually. Where in the world's my website? Okay. 4 decimal places. So 0.7224, 0.7224. And it says power of the test is 1 minus beta. So I have 1 minus 0.7224. So 1 minus 0.7224, 0.2776. Okay, so beta is 0.7224, and our power of the test is 0.2776. Both your answers are incorrect. Okay. True population is 0.47. 0.47, 0.47. That. Well, let me go through the steps again. Draw a picture, ZA sub L. Okay, left tail, NV norm alpha. NV norm of 0.05. Round to 3 decimal places. Negative 1.645. P hat sub L is P naught. Number from our claim, which is 0.5 minus 1.645. 0.5 times 1 minus 0.300. 0.5 minus 1.645 square root 0.5 times 1 minus 0.5 divided by 300. 0.453. 3 decimal places? Yeah, 3 decimal places. Wait, run slide. Okay, round to 3 decimal places. P naught is number in the claim. Yeah. P hat sub L minus P over square root of P. Okay. 0.453 minus true population proportion is 0.47. 0.47 divided by square root of 0.47. Okay, divided by 300. Second inner, second inner, second inner, second inner. Okay, 0.453 minus 0.47 divided by square root of 0.47 times 1 minus 0.47 divided by 300. Then I round that to 2 decimal places. And I get negative 0.59 2 decimal places. And then left tail, we got beta is equal normal CDF. Z What if I put the all of that answer in there? Okay, I'll put all the previous answer in there, comma, E99. .7224. No, doesn't matter about that. I still get .7224. Let's see, help me solve this. Okay. Continue there. Okay, whatever the answer is there. Okay, whatever. Check answer. Okay, that's fine. I'll get this. Continue. This should, I guess, correspond with this right here. So I think that should be 0.50. Number off of our claim. And this would be 0.50, 0.5, and 300 was in. Check answer. Okay, that matches our, this right here. Matches that. 4 decimal places. Ah! So if I come back to here, let's see what that's equal to. So let's see, we got 0.5 minus 1.645 square root 0.5 times 1 minus 0.5, which is 0.5, divided by 300. And we get 0.4525. 0.4525. 0.4525. Now I'm going to plug that in here. 0.4525, and I'll go ahead and continue with the problem there. Let's see if this is one's 2 decimal places. Okay, so 0.44525. Okay, so then continue there. Okay, now here it's kind of bizarre, but this to the what's to the right of the greater than, that matches what we have right here. 0.4525 minus 0.47 divided by 0.47 minus 1 minus 0.47 divided by 300. 4 decimal places again. Okay. So if I plug that in, and I'm doing this on this piece right here. So I got beginning parentheses 0.4525 minus 0.47 close parentheses divided by square root of 0.47 times 1 minus 0.47 close parentheses divided by 300. The 4 decimal places would be negative 0.6073. So 0.6073. 6073. I didn't put negative. Let's try it again. Negative. There we go. Now, This normal CDF here is still going to be the same, but we're going to put in a negative 0.6073. So we'll have normal CDF. So second of ours, normal CDF, and negative 0.6073, comma, E99, 0.7282. So 0.7282. 0.7282. Then we do 1 minus that for the power of the test. So 1 minus 0.7282, 0.2718. 0.2718. And that's how you do that problem. So it looks like on my my PowerPoints here, I need to make some corrections. See if I can remember where that's at. This one, although I can't change this, that's nice as an image, but I guess I can tell you. This should be 4 decimal places here. And on this one here, this should be 4 decimal places. And then that should give you the correct answer on the figuring these probability of type 2 error / power of a test problems.